Hi, this is Clayton with Mind of Its Own Design. Today I'm going to talk to you about lasers. What are they? Why do they work? How do they work? I'm going to be getting into some of the physics and the engineering behind lasers. First of all, what is a laser? A laser is a collimated beam of light, meaning it doesn't diverge very much when it comes out, and you can focus it, and you can take this beam of light, you can make it bigger or smaller with optics. Lasers are one color usually, meaning they also have one single wavelength that defines their color. Lasers are coherent. Now, what does that mean? Coherence is a sort of keeping together of like things. So I'm going to tell you about how waves of light are made, and then how they're trapped by mirrors, and then they escape in the form of a laser. So, first thing you need to know is that light is a wave. It has the properties of waves, like a wave in the ocean, a liquid wave, or a sound wave, or a light wave. They share all their similar properties. Now, when you have a wave, this distance between peaks is known as the wavelength. When you have a laser and it's producing a single color, that single color corresponds to a single wavelength. In this case, green, which is in the mid 500 nanometer wavelength range. How do you get this unique single wavelength of light? Well, it's a multi-step process. Number one, you have a lasing material, lasing media, sometimes it's called. This material originally was a ruby and red lasers, and now is synthetic ruby. And now you can have different compositions. This one obviously produces a green color. When you have this special crystal that can be excited in a certain way, then you excite it. This is a flash lamp, which is wrapped around the laser. A flash lamp is going to produce light, very high intensity, but going in all directions. Now, when it goes into this crystal, that light, in the form of photons, which is the smallest particle, so to speak, of light, the smallest packet of light, is another way to think of it. So one photon of light strikes this lasing media. See, I have some atom here with a cloud of electrons around it. When a photon from that flash lamp of a high energy comes in and hits an electron, that electron absorbs the energy of the light. The electron, the negative charge part of an atom, which has very little mass, it can be excited to a higher energy state. When the light hits the electron inside of a crystal, or sometimes a tube of gas or a tube of liquid, this electron gets excited, higher energy. When the electron comes down to its rest state, it's lower, sort of a neutral energy, that energy input that caused the electron to be excited now is released. And when you have a certain material that's being excited by this light from outside, the piece that's released when the electron relaxes its energy is a photon. Now these photons, in this case, have this wavelength, and they go everywhere out of this crystal. They shoot every direction. But some of them go out the ends of the crystal. They end up hitting one of two mirrors. This one is a full mirror, a full silvered mirror, sometimes they say, like, because a mirror is a silver on behind clear piece of glass usually. So when you're coating a piece of glass with the silver, if you don't coat it all the way, you coat it halfway, you have what is known as a half silvered mirror. What does that mean? It's kind of like the smoked glass version of a mirror, meaning that some light of a certain intensity will go through. Other light will be bounced back if it's at a lower intensity. Now, the property of waves is that when you overlay similar, identical wavelength waves with their amplitudes lined up, or coherent, the term is used to apply to lasers, these waves of light reinforce each other. They amplify each other. So laser is actually an acronym. Light Amplification by Stimulated Emission of Radiation. Okay, let's break it down. Light amplification. So when you have this mirror space, that's a multiple of the wavelength. These waves can be trapped between the two mirrors and form light's version of a standing wave. When you keep bouncing this light back and forth, lining it up with itself, it then becomes amplified to a greater and greater extent, eventually reaching such an intensity that this half mirror can no longer contain the light, and it comes out as a laser beam. This laser is collimated. Collimation, it's like a beam. It's a narrow beam, and it also means that you can focus it or expand it, or you could make you could use a beam expander and have a collimated beam, but now of a wider diameter. You can do a lot of stuff, and you use optics to manipulate lasers once they're out of this mirror. Now, the other feature of a laser is coherence. Coherence is the fact that these wave packets are now lined up with each other. They are coming out together, and they stay together for a while with low divergence. And they're also the same wavelength, or they have a coherent wavelength, or another term for that is a color. So there's a uniform color. This is a white light flash lamp, but it produces this green laser because the green is a function of the physics of the excitation, right? So that's stimulated emission. That's this part. Stimulated emission of radiation is the process by which an electron gets excited, then becomes relaxed, then releases photons. So again, you have light that's being amplified by the process of using one light to create the amplified light in another light inside of this crystal. So you're amplifying the light inside of the crystal and then lining it up in these mirrors back and forth so that it becomes coherent and more intense, and then just kind of like a water breaking through a poorly made dam. Once you get to a certain point, you could have a steady state. Some lasers operate in a steady state, which is like overflowing of the top of a dam maybe, or others act like that, like a bucket that's filling up over time. And once it creates enough enough coherence of the light back and forth, it all gets released like a bucket just dumping, that's been filling gradually with water and dumping it all at once. So that's like in terms of a laser, that's a pulsed laser. And in terms of a laser like this one that could just be on all the time, they call that continuous wave laser. So, and one more thing, lasers aren't going to just burn through like they do in the movies is missing out on one of the amazing features of the laser, which is the ability to be focused. I mean, your eye can focus the light of the world and it creates an image, but when you focus a laser, you're taking all of its energy, which you might think of as energy per cross-sectional area. And when you focus it down, you are putting all of that energy, which has to go somewhere, you're now putting it in a smaller diameter. And it's that process of taking a laser and focusing it down from a column to a very small point, that is when you get the truly amazing effects of lasers, where you can drill through metal, or you can shoot a missile out of the air by igniting its fuel. You can use it to read the zeros and ones inside of a DVD player, if you can find one of those. You can make these laser pointers. You can make machining lasers that can cut things. You can make lasers that are used for welding. Their applications are limitless. But remember, you need to focus in order to achieve the best results. Please like and subscribe, and check out mindofitsowndesign.com